Hello everyone and welcome to Kiru's online lectures. I am Kira Jamtani and today's topic is Aldehydes, Ketones and Carboxylic Acids Part 2. In Part 1, we studied Introduction, Nomenclature and Structure of Carbonyl Compounds. In Part 2, we are going to study preparation of aldehydes and ketones. So, moving on to the preparation of aldehydes and ketones combined. So, first is by oxidation of alcohols. So, primary alcohol on oxidation will give aldehyde, and whereas secondary alcohol on oxidation it gives ketones. So, this is the combined reaction of aldehydes and ketones of their preparation. So, first is primary alcohols on oxidation gives aldehydes, secondary alcohols on oxidation gives ketone. Moving on to next, by dehydrogenation of alcohols. So, this method is basically used for volatile alcohols, and in this method alcohol vapors are passed over metal catalyst like silver or copper. So, if we have primary alcohol on dehydrogenation, that is removal of hydrogen in presence of metals like silver or copper. So, primary alcohols give aldehydes and secondary alcohol gives ketones on dehydrogenation. Next is from hydrocarbons, which we have already studied. First is by ozonolysis, second is by hydration of alkynes. By ozonolysis of simple alkenes, that is like we have CH3, CH, double bond CH, CH3. This is simple alkene. So, simple alkene on ozonolysis will give 2 moles of aldehydes, that is CH3CHO, CH3CHO. These reactions we have already studied in alkenes. Similarly, if there is a branched alkene, so this branched alkene will give 2 moles of ketones, thus CH3CO, CH3. Hydration. Now, if we are performing hydration of alkenes, that is addition of water to ethyne, like we have CH triple bond CH. So, CH triple bond CH will give in presence of HgSO4 and H2SO4. If we are taking ethyne, in this case we will get aldehyde, but all alkenes, that is if we will take propyne or if we are taking butane, in all these cases we will be getting ketone. So, ethyne gives aldehydes, all alkenes gives, all other alkenes except ethyne will give ketone. Now, moving on to the preparation of aldehydes only. Now, we will be discussing the reactions through which only aldehydes can be prepared. So, the first is from acid chlorides, that is acyl chloride. So, here what happens? Acid chloride is hydrogenated, that is hydrogen is passed over it over catalyst palladium or barium on barium sulfate. This reaction is Rosenmund reaction. So, we have acid chloride, that is benzoyl chloride, COCl. This is hydrogenated with palladium over palladium on BaSO4. So, here we will get CHO, that is benzyl chloride. So, benzyl chloride will give benzaldehyde. Moving on to next, which is from nitriles and esters. So, from nitriles like we have RCN. So, these are reduced to corresponding amines if the reaction takes place with stannous chloride in presence of HCl. So, first we will get RCH double bond NH, which is imine, On hydrolysis, it will form RCHO. So the first reaction was Rosenmund reaction, and the reaction from nitriles is Stephen's reduction reaction. So Stephen's reaction. Nitriles, these are also reduced by diisobutyl aluminium hydride, which is known as Debal H. So RCN is also reduced by Debal H, diisobutyl aluminium hydride. Now first it is reduced to imines, again followed by hydrolysis it forms aldehydes. Similarly, if we have a double bonded cyanide nitrile, that is CH3, CH double bond CH, CH2CN, Debal H will give, followed by hydrolysis, aldehyde only. This double bond won't be disturbed, thus we will get CHO. Similarly, esters if we have, so esters are reduced to aldehydes, like we have CH3 CH2 whole 9 CO OC2H5. So here this bond will break and thus OH will and thus will write H because hydrogenation is taking place. With Debal H will get CH3 CH2 whole 9 CHO. So this is how we can prepare aldehydes from acid chlorides, nitriles and esters. Moving on to next preparation of aldehydes, that is from hydrocarbons. From hydrocarbons, so the first is oxidation of methyl benzene. So methyl benzene we have, that is toluene. So this is methyl benzene. First is by the use of chromyl chloride, which is CrO2 Cl2. So chromyl chloride will oxidize methyl group to a chromium complex. So here we will see a chromium complex, that is CHOCrOHCl2 whole twice, which on hydrolysis will form benzaldehyde. So this is how we can prepare aldehydes from toluene, and this reaction is known as Ettard reaction. Next is methyl oxidation of methyl benzene only, but now by the use of chromic oxide, which is CrO3. So toluene or substituted toluene is converted to benzylidene diacetate, because over here we are taking acetone CH3CO. So thus we will get benzylidene diacetate, which is CHOCOCH3 whole twice, which on again hydrolysis will form benzaldehyde, which is CHO, benzene with CHO. Moving on to next, from hydrocarbons only. Now by side chain chlorination followed by hydrolysis. So we have this toluene which reacts with Cl2 in presence of UV rays. Thus we will get CHCl2 on hydrolysis at 373 Kelvin. We will get benzaldehyde. Last is for the preparation of aldehydes, Getterman-Koch reaction. In this reaction, benzene or its derivatives, like this is benzene or its derivatives, are treated with carbon monoxide HCl in presence of anhydrous aluminium chloride or cuprous chloride. So it gives over here benzaldehyde. So in preparation of aldehydes, the first reaction was from acid chlorides Rosenmund, from nitriles and esters, then from hydrocarbons. So, first was by oxidation of methyl benzene, then by side chain chlorination, and then Getterman-Koch reaction. Now, moving on to the preparation of ketones. So, for ketones, the first reaction is for acid from acid chlorides. So, with acid chlorides, how we prepare? So, first of all, we take over here Grignard reagent. This Grignard reagent reacts with cadmium chloride. It forms dialkyl cadmium plus MgX and Cl. This dialkyl cadmium reacts with acid chloride. So, we have R-COCl plus dialkyl cadmium. Here Cd and Cl will be replaced. Thus, we will get R-COR. 2 moles of acid chloride will take, and this is how ketones are prepared. From nitriles, like we have CH3CH2CN, so it reacts with Grignard reagent CH3MgBr in ether. Thus, we will get CH3CH2C. It is triple bond, so here we will get double bond NMgBr, and here we will write CH3. Thus, on further hydrolysis, this bond will break. Here O and here OH will be given. So, here H2 will be given. So, we will get CH3, CH2, COCH3. So, this is how we can prepare ketones from nitriles. The last reaction for preparing ketone is from benzene or substituted benzene. So, we have benzene. So, benzene or substituted benzene, they are treated with acid chlorides, that is RCOCl, in the presence of anhydrous AlCl3. So, basically over here COCl group attaches over here in the benzene group, COR group, sorry. So, COR group attaches here, H and Cl is removed. Thus, ketones are prepared, and this reaction is known as Friedel-Crafts acylation reaction. So, in today's video, we studied how to prepare aldehydes and ketones. Hope you guys are finding videos helpful. So, do like, share and subscribe the channel. Thank you.